Yeah, my name is Rick Stehno. I work for Seagate and work with databases and Ceph. And a lot of my presentation is going to be on Ceph, but in the beginning I'll go over some background details. So according to Gartner and other surveys, data doubles every 18 months to 24 months. There's a trend on more and more companies are looking at the cloud to store their data. And at the same time, IT budgets are relatively flat. What this doesn't tell you, what the surveys don't tell you is the more data you have, the slower access can be with the bigger data. And also it doesn't tell you that you need more cooling costs, electrical costs, floor space for all this storage. So at Seagate, we have a lot of different devices. And your kinetic hybrid drives, your PCIe flash cards, SSDs, and those devices are actually used in the arrays, like software-defined storage, hybrid, flash arrays. And those arrays are then used in converged infrastructures, engineered systems. So at Seagate, low latency, high cost per gigabyte. We create all the different PCIe flash cards, SSDs, all the way down to archival HDDs, which are your high density, low cost drives. And this is per gigabyte. But then what happens is this changes when you go against performance. Your PCIe flash cards are more expensive initially, but per IOPS, they're the cheapest things out there. And so what I'll show later on is how we can use some of these devices to help the high density disks perform better at a cheaper cost. In Ceph, you have a lot of OSDs writing on top of file systems like BetterFS, XFS, or ext4, and then those file systems reside on disks. And you can have tens to 10,000 OSDs per cluster. You could just keep building the cluster. You have one OSD per hard drive or per SSD per PCIe flash card. We store objects for clients to access. There's intelligent peers to actually do the replication and recovery within Ceph. There's erasure coding and support for strong consistencies leveraging the rights to journals. So what I'm going to be talking about, because the data is growing, we create SMR disks, shingled magnetic recording devices. They're high density, low cost, very low cost, great performance for sequential reads and sequential writes. They perform less on random I/O for writes. And also part of this, we also use our PCIe flash cards, which are excellent performance, but at a high cost per gigabyte. I've been working with a lot of customers and partners on developing reference architectures for Ceph. And what we've been using is our Nitro card, our flash card. So we make them up to 4 terabytes right now. And our Nitro XD, we actually have some host-based software that caches all the writes. Whether we actually build a write-back and a write-through caching software. So in this case, I'm doing a lot of testing with writes because our SMR disks perform less in a Ceph environment doing random writes. So our XD, our write-back technology, and then we have each server has 12 8-terabyte SMR disks. So just by itself, we cache, as a default, all the Ceph journals and metadata onto the PCIe flash card. And by moving this data into flash, we could save actually over 40% of the cost compared to typical CMR or conventional disks.
Are we protecting ourselves from all of these cards?
Yes. Yeah, it's persistent memory. It's persistent through reboots. And we've seen as much as 40% decrease in costs over conventional disks, and I'll go through that later. And actually, in certain writes, I've done extreme writes, like 4K writes and 4 meg writes. And in some cases, we got 11 times performance gains by implementing our caching software with SMR disks over versus CMR drives. So here's some charts. So when you talk to people about SMR disks versus conventional hard disks, they'll say SMR disks perform badly. And in this chart, in some of my testing, you get about a 10% decrease in performance using SMR. But again, I'm using an 8 terabyte SMR disk versus a 4 terabyte conventional disk. And if you do some of the testing results over there in the 4 meg writes, we actually perform much better, including our caching technology with our SMR drives over conventional disks. And you get a little bump in performance. It's pretty good for 4 meg. And in our 4K writes, we actually do much better over CMR disks. And in my testing here, I'm using a default of 32K for caching. So everything under 32K, we cache onto the PCIe card. Anything over 32K, it's going right to disk. So that's why in the 4 meg, you're not going to see as big of an improvement as you will with the 4K. And the software is tailorable, so if you wanted a 64K, 128K caching, we can do them. So in some of the tests, in different technologies, SMR only, we got this performance for megabytes a second. And then when you actually separate out the journals onto an SSD, which some people do, you don't get much increase at all. And that's the trend that people have seen. And I've used Ceph's SMR cache tiering, and you get a little bump, twice the performance. But when you use our caching technology with our PCIe flash, you get a much better 11% or 11 times performance gains. And in the that's with 4K write 16 thread. And in our latency is also 11 times less latency going to our flash. And in 4 meg, you'll see performance differs. You get not as big of a bump, but because these SMR disks perform better with the larger, but you still get much better performance, probably 6 times, 7 times using our SMR with XD. And that's, again, just the journals and the metadata are cached onto the card. You'd see much better performance if I would say 128K to cache versus the 32K default. And same thing with the latency. You get a 6 gain increase in performance. Here's a cost for how to implement our SMR disks with our PCI card. So cost per gigabyte, we're 1/3 the cost of a conventional hard disk. So very cheap, 3 cents per gigabyte. And if I take the megabytes per second gains, including our PCI flash card, so it's $3,000 for the PCI board, the 12 8 terabyte SMR disks, we cut the cost in half almost. And these costs don't include the reduction in floor space, cooling costs, and so forth. This is just the raw hardware cost for the hard disk and our PCI flash. And 4 megabytes, because we're not caching as much, it's more even. Again, I could tailor that and make it better, but just for extremes. And these graphs show the different costs and megabytes per second costs. So we did a show at OCP last year, and working with a customer, you could build an OCP rack of 18 Winterfell servers with 33 terabytes of flash and 2 petabytes of data, disk space on one server, on one rack. Thank you.